Question number 21 says inequality 2x minus 3y plus 24 is greater than 0. The positive y-axis, negative x-axis. It defines a region in quadrant 2. So determine the area of this region. So there's a few ways we can do this. So first of all, we need to graph this dotted line, and the area in this region is going to be this region in here. Okay, it's all in the second quadrant. If we want to find the equation of that line, we could graph this on Desmos like I did. If we want to graph this by hand, we probably want to put this into y equals mx plus b. So I'm going to solve for y, which means I'm going to add 3y to both sides. I don't need to worry about dividing by the negative. If I kept it on the other side, I would have to flip the sign. But in this case, y is less than, and it's going to be 2 over 3x, so there's my slope, and then plus 8 represents the y-intercept. Okay, so we can see the y is less than, so the area is below, and this slope has 3 over 2, positive 3 over 2, and a y-intercept of plus 8, and we can see there's our y-intercept of plus 8. So it says, how does the area of this region depend on the y-intercept of the boundary of the inequality? Well, the boundary is going to be then the max value of this line. So that's going to represent the boundary point of this region. So it's going to be defined by the y-axis. So we stop at the y-axis, so we need to know the y-intercept to know the boundary. It says, how does the area of the region depend on the slope of the boundary of the inequality? Well, if the slope gives us the slope of this line, the boundary line. And then D, it says, how would your answers for our B and C change for the regions with the same shape located in the other quadrants? Well, if it's in the other quadrants, we know that that boundary 8 is a starting point of that line in quadrant 1. And then we would be taking the area in quadrant 1. So we would kind of section that off. That's my boundary line. The slope still represents the line that defines the line that's defined, which we need to find the area under, and we're looking for that. In quadrant 3, okay, all of quadrant 3 represents the solution. So sorry, quadrant 4. All of quadrant 4 represents the solution, so it doesn't matter. The y-intercept and the slope of that line are not relevant to the problem. And then for quadrant 3, we know that the slope still is relevant because it goes off down here, and we are finding this area underneath. Okay, based on, we're still going to shade this area down here. So it's still dependent on the slope, but it has nothing to do with y-intercept, but more to do with the x-intercept, because that's the boundary point at which we start shading from.